So we just talked about the carbon cycle and how carbon moves from place to place, whether it's from the atmosphere to the soil, to our organisms, to eventually becoming fossil fuels. And what we're going to focus on now is just fossil fuels, that coal, oil, and natural gas. And really, what are they? How did they come to be? And then kind of talking about humans and our relationship, so to speak, with fossil fuels. So we have three major fossil fuels. The first one we'll talk about is coal. The way coal was formed, and it was formed millions of years ago, was Earth used to be very swampy. A swamp, kind of like in this picture, is very acidic. The soil is very watery. There's a lot of acid in them. Don't think battery acid. It's more of a weaker acid, but acidic enough that there wasn't many decomposers there. There was a lot of bacteria that couldn't survive in swamps, a lot of fungi that couldn't survive in swamps. And so what happened is that when organisms died and they landed in a swamp, so for example, any of these plants, if they die, they fall over. If they die in that swamp, there's actually no decomposers there. That's it. So they just fall over, and all that remains is the plant itself. Now, this is happening for hundreds and thousands and millions of years, that these plants fall and fall, but they don't decompose. So essentially, you've got a whole bunch of plants layering one another. Now, what happens is that this vegetation, as it's compacting one another, it's getting more and more compact, so there's a lot more pressure, a lot more weight there. And you also get a lot more heat, so you're pushing this further and further down, and the further you go into Earth, the warmer it gets. So essentially you take dead plants, and I do emphasize plants, so dead plants on land, they fall into the swamp, they compact and compact and compact, they add a little bit of heat, you add a couple thousand, hundreds of thousands of years, and you have coal. Now this coal, the reason it's deep into Earth is because, again, everything was compacting on one another. Now this is the molecular structure of coal. I am not going to ask you to draw this or anything like that, but I point this out for a reason. Each one of these rings has a carbon in it. Oh. We'll talk about that picture in a second. Each of these rings has a carbon in it. So this is a carbon, 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 carbon. So each one of those rings has 6 carbons in it. And as you can see, coal has tons and tons of these rings. So coal has high carbon content. So it has tons and tons of carbon. And I mean, that's to be expected, and that's not necessarily bad, but I'm letting you know this because we're going to compare carbon content between coal, oil, and natural gas, and coal has the most. Now, this picture, this is a picture of Bog Man. Bog is another word for swamp. Bog Man was someone who died hundreds of years ago, and his body was recently discovered in the past decade in a bog. You can see he is nearly perfectly preserved. It almost looks like some sort of dummy, but this is a real person that died hundreds of years ago. You can even see his facial stubble. You can see the wrinkles on his face. Apparently, maybe he was hung or something. That's their guess, at least. But he's more or less perfectly preserved. And the reason why is because he was placed in a swamp where there's not decomposers. His body and all the carbon in his body is still there. So this is exactly what happened with those plants in swamps millions of years ago, is they died and fell, but they didn't decompose. So that carbon was stuck in that plant. You compact it for a couple thousand years, couple million years, add some heat, and then eventually that carbon churns in those plants churns into carbon-rich coal. So that was for coal. Oil is formed a little bit differently. Instead of it being land organisms, we are now going to the aquatic world. And it's both aquatic plants and animals. So here in this picture, we have our ocean ecosystem. You see some plants in here. There's tons of different animals. And what happens is those organisms die. They fall to the seafloor. Depending on the conditions of the seafloor, there might be decomposers or there might not. In areas where oil formed, there weren't decomposers. Those aquatic plants and animals didn't decompose. So all the carbon in their bodies, well, that's still carbon. It didn't go back into the soil. It stayed in those bodies. And this is happening over and over and over and over again. Now, when this is happening, you get that layering, you get that pressure acting on it. And when you get more pressure and you get closer to the inside of Earth, you're also getting more heat. And similar to coal, the carbon in those bodies gets transformed into a fossil fuel, but in this case, it's oil. And so this fossil fuel, this oil fossil fuel, also has lots of carbon in it, but as you notice, not as much. These are a couple different compounds of oil. For example, this one has 1, 2, 3, 4, 5, 6, 7. This has 8 carbons. This one has 1, 2, 3, 4, 5 carbons. Significantly less than what we saw with coal. With coal, we were seeing hundreds of carbons. So there's still carbon in it. That carbon has energy that we as humans use, but just not nearly as much. That doesn't mean we don't get as much energy. We still do get quite a bit of energy from our oil. I also want to note is that in this picture you also see us, drilling for oil right here, but we're on land. It's land now, but maybe a couple million years ago it wasn't land. So wherever we drill for oil, that actually also tells us that that used to be an ocean. Where Texas is today was an ocean at one point, which is really cool to think about. Natural gas is very, very similar to oil in the sense that they're made by the same things. Natural gas is also made from aquatic plants and animals. I mean, I'm just using the same image at this point. So we have this ocean full of organisms. Those organisms die. They don't decompose. They compact and compact and compact on one another. It gets hotter for them. But it needs to be deeper. It needs to be hotter in order for those organisms to be turned into natural gas. Usually, not always, but usually the organisms, or it turns into oil first, and that oil then turns into natural gas, just depending on how long it's been and where exactly it's located. This is usually why when people are drilling for oil, there's usually natural gas there as well. We talked about fracking in our last unit, hydraulic fracking, where they're using drills to drill for both oil and natural gas, because they're usually found with one another. So they are formed very similarly. It's just you need more heat and more pressure in order to turn that oil into a natural gas. Natural gas also has the least amount of carbon. If we look here, there is 1 carbon. Natural gas is also methane. We'll talk about methane more a little later this unit, but methane is when you have natural gas in your house, you're actually burning the gas called methane. This has 1 carbon, and that's it. So that difference, we saw coal having the most and natural gas having the least, just keep that in mind. Again, I'm not going to ask you for these formulas, just keep a note of the relative abundance of carbon in these molecules.